Oxygen molecule. Oxygen atom has 8 electrons. So it is 1s2, 2s2, 2p4. In molecular orbital diagram, we will have this configuration where this is one oxygen atom, this is the second oxygen atom, this is O2 molecule or linear combination of atomic orbital. This is our energy diagram, the energy levels. 1 is at a little higher energy, 2s, and this is our 2p. For the next oxygen atom also, this is 2p, this is 2s, and this is 1s. Now, the electrons are filled up as 1, 2, 3, 4, 5, 6, 7 and 8. Here also we have 8 electrons. In this oxygen molecule, when these two atomic orbitals will superpose, they will have two molecular orbitals. One will be of lower energy, another is of higher energy. This is our sigma 1s and this is sigma star 1s. This is our sigma 2s and this is sigma star 2s. Now this will first form the, unlike this, either for an atom number of electrons greater than equal to 8 or could be for a molecule that is greater than equal to 16. We will have the sigma 2pz first, the lower one, followed by pi bonding, and in anti-bonding this will follow first pi anti-bonding followed by sigma anti-bonding. So we have the arrangement like this. The names will be, this is sigma 2pz, pi 2px, pi 2py, pi star 2px, pi star 2py, sigma star 2pz. The electrons could be filled up as one oxygen we have 8 electrons, so in O2 we will have 16 electrons. 2 to 4 to 8 to 2 to 4 to 6 to 8, 9, 10, 11, 12, 13, 14, and in anti-bonding we will have single electrons. Now the reason is why actually it happens. Up till nitrogen we have seen that the anti-bonding pi orbitals do come as a lower energy level, and in oxygen onwards or even in any other heteronuclear species which is having electrons, heteronuclear molecule with electron more than 16 or more than 16, why such arrangements do take place, that the sigma 2pz orbital comes as a lower energy level and pi goes higher. Now here is the reason that in case of boron or any other boron, carbon and nitrogen, we have seen that the sigma 2p, sigma 2s and sigma 2pz, because this is in internuclear axis, this will have same symmetry. So these orbitals will overlap and result in the formation of two bonded sp-Z orbital. In case of boron, carbon and nitrogen, what did I say? This sigma 2s and sigma 2pz. These two are in internuclear axis. In sigma 2pz, we actually have this due to the same symmetry, these orbitals overlap, and therefore it forms actually SPZ character or SPZ orbitals. So this overlapping actually forms two SPZ orbitals. This SPZ orbital so obtained, so thereby this is actually this 2pz orbital would be obtained in some way is having some of the S character. This 2pz what we are getting, this is having therefore the S character. So since it is having this S character, it will become little unstable and of course with higher energy than the corresponding pi bonding molecular orbitals. On the other side, due to this overlapping only, this sigma 2s molecular orbital gets somehow this p character. So the energy level diagram of this sigma 2p orbitals will come faster, as finally that the molecular orbital energy level molecular orbital diagram will show that sigma 2p z will have higher energy than pi 2p x and pi 2p y in case of boron, carbon and nitrogen, and thereby for boron, carbon and nitrogen we have the configuration sigma pi 2p x, pi 2p y first, followed by sigma 2pz bonding molecular orbital. In case of oxygen, what we can see over, due to this higher nuclear charge of oxygen, the energy difference between 2s and 2p is quite large, and therefore there is no such kind of intermixing like SPZ. So it's obvious that this is not present in case of that SPZ character, or this intermixing is not present beyond this oxygen, fluorine or neon or higher one due to the higher nuclear charge, and the large gap between 2s and 2p suggests that since such no intermixing is there, there is a sharp band between this 2s gap and after that the 2p starts. So in case this starts, it's obvious first the sigma bond would be formed, after that pi bond would be formed. This boron, carbon and nitrogen whatever is formed earlier, this is actually exception. This is the correct order or the expected order, not the correct one. This is the expected order where the 2pz or sigma 1 will be filled first, followed by the pi bonds would be formed. And since sigma bonding is always preferred, its anti-bonding would have the higher energy, and in case of pi the anti-bonding would have the lower energy. Keep one point in mind, that anti-bonding always challenges the bonding. So we have this molecular orbital diagram. Now we'll come to the molecular orbital configuration. The molecular orbital configuration of oxygen molecule would be sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2. After that sigma 2pz2, pi 2px2, pi 2py2 and pi star 2px1, pi star 2py1. So the configuration makes that molecular orbital diagram is like this. This is sigma this pi would be filled like this according to Hund's rule, and anti-bonding pi would be filled like this. Since the anti-bonding pi contains unpaired electrons, this is oxygen is paramagnetic in nature. While finding the bond order, we do expect that in between dioxygen we have the double bond. Now we check the strength of oxygen bond. These are the anti-bonding orbital. Even this is the anti-bonding orbital, this is also the anti-bonding orbital. So these are the anti-bonding electrons. These are the anti-bonding electrons. We have as a whole 2 to 4 and 2 6 anti-bonding electrons, and the bonding electrons would be 2, 4, 6, 8 and 10. So it is 10 minus 6 by 2, that is 4 by 2 or 2. It is obvious that oxygen we always have a single bond character, and it is further paramagnetic due to unpaired electrons in anti-bonding pi orbitals, and the spin only magnetic moment is equal to square root of 2 plus 2, where this 2 is the number of unpaired electrons we got, that is square root of 8, or that is 2.8 Bohr magneton. So this is how this oxygen and boron's paramagnetic nature or magnetic behavior is being explained. Now let's see, in case this would be fluorine and neon. Please pay attention over here. In case this is F2 molecule, again I will not do this fluorine and neon molecule, I'll just show this. If it is fluorine, it will be 9. This is 1s2, 2s2, 2p5. Out of all this will remain same. This will be F atom, F2 atom, the linear combination, and instead of this 4 electrons, another 2p would be completely filled. So this is 2p5, and for this fluorine is having 9 electron, F2 would have 18 electrons. 18 electron means 2 more electrons would be filled, and then the pi star 2px and 2py both would be completely filled up. Thereby fluorine will have a configuration of F2 would be, you will make the molecular orbital diagram by yourself. Sigma 1 is 2, sigma star 1 is 2, sigma 2 is 2, sigma star 2 is 2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2 and pi star 2py also 2. So it is also completely filled up. No unpaired electrons are present. This is our bonding pi orbital, and this is anti-bonding pi orbital. The bond order will be half into bonded electrons, electrons in bonding molecular orbital minus electrons in anti-bonding molecular orbital. Let's mark the anti-bonding molecular orbital electrons. So these are the anti-bonding molecular orbital electrons. We have 8 anti-bonding molecular orbital electrons, and we have 2, 4, 6, 8 and 10 bonding molecular orbital electrons. Had it would be only bonding molecular orbital electrons, there is no challenge or no countering of the electrons with anti-bonding. So in that case, we have the bond order is equal to 1, which clearly suggests that fluorine is just having a single bond in between 2 atoms. Moreover, it is diamagnetic in nature. Now let's see last the neon molecule. In case of this neon molecule, this neon would be 10. And then this is 2p6, 1s2, 2s2, 2p6. And it be then completely all the 2p electrons would be filled, and in case 20 electrons are there, all these 10 molecular orbitals would be completely filled. Then the molecular orbital configuration of neon would be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, pi star 2px2, pi star 2py2, and sigma star 2pz2. So that is all the 10 electrons would be completely filled. This is the bonding pi molecular orbital, this is anti-bonding pi molecular orbital, and this is anti-bonding sigma molecular orbital. All that electrons would be filled, and since it is sigma star 1s2, this is sigma star 2s2, this is pi star 2px, pi star 2py, and sigma star 2pz. This all would be anti-bonding electrons. And then we have bond order is equal to half into 10 for bonded electrons minus equal challenge, that is same amount of anti-bonding electron, and that's why there is practically no bond existing. Whatsoever bond is being formed, this is equally challenged by the anti-bonding orbital, means it has similar extent combination of in phase and out phase, so that neon molecule does not exist, Ne2 does not exist, or neon is a monoatomic species, as we have seen this in case of other noble gases also, helium and in beryllium also, wherever no bond is being existing.